Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ali Yusuf. I'm section 2. Today I'm presenting for our group project for designing for centrifugal pump. And here is the here is the group for the project. And here we have a company, consultancy company, CPE, control pump efficiency company. And it's a consultation company. If you need for any information, you can take the information for the QR code. I'm going to introduction. CPE control pump efficiency is leading engineering consultancy firm with a proven track recording of delivering high quality, innovative solution for the fluid handling system. Our team experienced engineers and technician expertise has combined experience of 30 years in the field. And we are committed to deliver customized solutions that needed the unique needs for each our clients. In this project, we have been engaged by UTM, the First Technology Malaysia, to provide a consultation for centrifugal pump designed to deliver fluid. The client has provided us with the performance data obtained from a test on 216 mm level in centrifugal pump, moving water at consultant speed 1350 RPM. This data will be critical component in our analysis and design work. We will be used to determine the best operation condition for our pump and make a necessary adjustment to ensure its effective performance. The performance data we will also consider that the plan process, purpose, from location, develop and project schedule, including the Gantt chart format, and create the details schematic for the pump and its associated piping and fitting. We also conduct a thorough analysis for the design, calculation, and selection process and compare to the theoretical head of the pump with manufacturer's performance curve to ensure that the most appropriate centrifugal pump is selected from the project. Our goal is to provide UTM, First Technology Malaysia, with a comprehensive, high-quality report that outlines our purpose and solution and provide the information needed to make the informed decisions about the centrifugal pump design project. We are confident that our team has skills, experience, and commitment needed to deliver solutions that exceeds the client's expectation and meet their specific needs. We also look forward to work closely with UTM to bring this project into successful completion. Thank you.
Hello there, my name is Jihan Onbimam Atahi and I will be continuing on explaining on the sketch design of the centrifugal pump system. So what you have here is a diagram of a fully functioning centrifugal pump system. So basically what this system does is transporting liquid from tank A into tank B. So let's look at each part. So first of all, there's tank A. As you can see inside tank A, we have implemented something that is called as a vortex inhibitor. So now what a vortex inhibitor does is, as the name suggests, it exactly inhibits the formation of a vortex. So why the formation of a vortex is not necessary or unimportant in the system is because a pump operates under its own circumstances. So it does not need any external forces to act upon it for it to function properly. So with that, having a vortex inside the tank forming itself it would cause some damage and also harm into the centrifugal pump. And as you can see at the bottom end of tank A, there's a bit of a slanted or tapered kind of design, and this is to help with the water flow from tank A going into the suction pipe, and this is to prevent the water flow to change into turbulent flow. What we want is laminar flow. And as you can see around the pipes, such as the suction pipe and also at the top of the delivery pipe, there is something that is called a pipe holder. Now, why are pipe holders important? This is to reduce or to decrease the vibrations caused by the water flowing inside the pipes. And when you have something that is vibrating, it will cause other things that is connected to the vibration to vibrate also. Now, we don't want the centrifugal pump to vibrate at all costs. There will be some vibrations, but it is our job to reduce the magnitude of the vibrations, hence why there are pipe holders holding the pipe, so that one is to reduce the vibrations and also to reduce the stresses on the centrifugal pump of holding the pipes. And now the main part of the whole system is the centrifugal pump. So the centrifugal pump has two parts. One is the suction pipe and also the delivery pipe. So the suction pipe is mainly to suck in liquid or water from tank A, and the delivery pipe is to transport the water from the pump into tank B, and this is all done by using a propeller which is installed inside the centrifugal pump. Now that is all from me. Thank you.
Assalamualaikum. My name is Afiq. I will start the presentation. So for the first graph, if head of pump versus discharge, you can see the trend line of the graph is increasing before the 1.5 and maintain the trend until 2. After that, decreasing uh, until it becomes 0. So for the second graph is pump efficiency versus discharge, the increasing of trends until 2.4 and slightly decrease after 2.5. For the third graph is power versus discharge. You can see the trend line is in linear increasing from 0.5 discharge until 3.5 discharge. So same goes to the head of pump versus discharge graph. It shows a trend line of linear increasing from discharge 2.45 until discharge 2.9. And the last graph is pump efficiency and head of pump versus discharge. The upper part, the blue side is the head of pump versus discharge legend, and the lower part is pump efficiency legend. From the two graph, we need to find the best operating point that cross these two uh, trend line of graph. So for the blue part, we can say that operating point is 2.6 using the formula HP equals to 5 plus omega QZ. So for the manual calculation, first we use these three unknown to calculate the third reading in the table, and we get pump power equals to 4,213.857 kilogram. So we have given that demand curve expression H equals to 5 plus Q2 Q square. Q demand equals to power root H minus 5. So from the graph, we can find the intersection point of discharge Q and head H. The pump efficiency from the performance detail of centrifugal pump at Q 2.7 using the pump power formula, we can get the pump power equals to 7.179 kilowatt. So for the final answer, we get the pump discharge Q equals to 2.70. For the head developed, we get 12.4 and the power required 7.179. So the discussion is we can determine the HD and the QD. using the intersection of the system curve and pump head discharge. So we get the value according to graph file is HD equals to 12.4, QD over equals to 2.7, and Q equals to 2.6. So any additional loss includes static head loss from pipe friction and small loss. The total loss coefficient in the system determine how steep the demand curve will be. As the loss coefficient rise, more pumping head will be needed to deliver a given discharge. Additionally, there may be additional variables influencing the demand curve, such as valve throttling and the uses of aging pipe, which could result in a long-term increase in loss coefficient. Thank you.